evolution, innovation, flexibility, key terminology which defines the situation faced by industry over recent years. New market demands, however, require a greater level of automation in production processes. Increased competition, the search for cost reduction and the increase in product quality all encourage the need for the aforementioned automation of processes. Classic technologies evolve while new ones emerge, creating a multi-technical environment in which they are all interrelated. The automation pyramid represents the different levels that can be found in an industrial environment. The pyramid base represents hardware and physical devices, such as sensors and actuators. The second level, or control level, includes logical devices like PCs or PLCs. In the next level, we'll find SCADA systems for the supervision and acquisition of data. In the fourth level, there are manufacturing execution systems, MES. The top of the pyramid is reserved for integral management and planning systems, or ERP. All technologies are interrelated within each level and between the different levels using industrial communications. This multi-technical environment means that specialization in specific technologies such as mechanics or electronics is not enough, and the technical personnel in the plants need to develop a series of key professional skills in order to undertake the work properly. Analysis, programming, troubleshooting, decision-making or team coordination are examples of the professional skills that are increasingly required. Technicians play a fundamental role in current productive processes. But do they have the level of qualification required? Are they prepared to face the current and future industrial reality? SMC International Training presents the HAS-200 system as part of its objective to contribute innovative training solutions with regard to industrial automation. The HAS-200 has been developed in conjunction with leading companies from diverse sectors such as pharmaceutical, semiconductor, automotive and food processing, all of which utilize the highest degree of automation technology. Several universities and training centers have also taken part in the design and development of HAS-200. The result is a piece of training equipment which enables the development of professional skills required by today's industry and, moreover, that of tomorrow's. The HAS-200 system has been designed to reach 5 levels of the automation pyramid. It is, in short, a real, highly automated factory adapted to the demands and budgets of a training environment. The HAS-200 simulates an actual production process with the ability of manufacturing up to 19 different products. Current technologies and highly automated processes are integrated into this completely modular and flexible system. The complete equipment consists of 11 working stations, totally modular, which form a fully automated manufacturing line. The raw material includes a container with 4 unique labels: red, blue, yellow and multicolored. Each label has a barcode for the identification of each product in the process. The containers are filled with various quantities of beads in red, blue and yellow. They are controlled, closed, identified, stored and shipped. The system allows both the physical distribution of the stations and for the process to be completely random, thus simulating a true industrial setting. Multicolored container feeding. It supplies the transport system with the multicolored containers to be filled on the production stations. As with the rest of the stations, it has a barcode scanner for identifying labels, a troubleshooting and breakdown repair system, and a quick change container warehouse, a function which is also carried out in the production stations and the lid positioning stations. Production stations. These allow the feeding, filling and weighing of the containers with the colors red, blue and yellow. The multicolored containers are also transferred to these stations from the first station to be filled with the quantities stated in the program. Control stations. They are responsible for measuring the height of the material filled in the containers. The additional section of conveyor in the control stations allows the study of concepts such as bottlenecks and works in progress. Both stations differ in the height measurement system, potentiometer or linear encoder. Positioning of lids. This is responsible for feeding the lid and closing the container, as well as printing and attaching a product identification label with information regarding the lot, manufacturing date, etc. Vertical storage. Composed of a 2-axis servo actuator system for storing up to 81 containers. Horizontal storage. This consists of a single-axis servo actuator coordinated with a single-axis stepper actuator, which can accommodate up to 56 containers. Both stations consist of a human-machine interface panel to facilitate the automated storage and retrieval process. Palleting. The last operation in the process is the palletization and shipment of the final product, grouped into blocks of 4 units that are shipped once the lot is complete. This station also includes the troubleshooting and breakdown repair system. Raw material store. This station enables the storage of containers, lids and beads to be made quickly available for resupplying the factory. All stations use state-of-the-art Ethernet-linked PLCs, capable of sequential control in both the manual mode as well as in the automated mode for establishing fast communication with the highest levels of data management. control cabinet contains an Ethernet hub with all the necessary electrical and pneumatic connections. The EDMES, Educational Manufacturing Execution Systems program, simulates real factory conditions and the most relevant functions of a manufacturing execution system. Each module allows for launching and modifying orders, establishing the layout of individual tools for lean manufacturing processes, generating reports using statistical process control methods, creating tool maintenance schedules, as well as analyzing the global performance of the production system for optimal equipment efficiency. For controlling and monitoring each station, the HAS-200 includes a three-dimensional supervision system called 3D Supra. Additionally, the communications topology allows for the remote control of this system via a virtual private network. The system's flexibility and special module design enables the composition of numerous configurations, responding to our clients' unique requirements and budgets. To encourage teamwork, the system's dimensions have been developed to allow several users to work on a station simultaneously. Furthermore, the HAS-200 is manufactured entirely using true-to-industry materials and components. All equipment is accompanied by a complete set of documentation and educational material, including technical manuals with information on each system's components, a comprehensive user's manual indicating equipment sequence, a collection of didactic units detailing the basics of highly automated systems, a collection of practical activities oriented to the development of the skills required in industrial automated environments, all these features make HAS-200 an excellent piece of didactic equipment for training qualified technicians in environments with a high level of automation. Many leading companies and educational centers put their trust in our training solutions.